Hello. Today we're going to go over CMOS and BIOS. CMOS complementary metal oxide semiconductor. Complementary metal oxide. I don't really know what any of that really. Complementary metal oxide. What I understand that to mean is that it's a battery. a little battery, one of these little circular C. It usually has the CRV2324. It's a watch. Usually these are found in watches. These little batteries. I think that's what this means. Complementary metal oxide complementary metal oxide semiconductor. I really don't know the significance of why we're saying all these words. Complementary metal oxide semiconductor. As far as I know, it's just describing the battery, which the CMOS it uses. That's a main point, is that the CMOS it uses this battery. So today, CMOS, before we get more into the battery, I haven't forgotten, we're going to get back to this. But as far as the introduction for today, what we're talking about the CMOS, complementary metal oxide battery, and BIOS. And BIOS stands for Basic Input Output System. Basically, not basic input output system. Okay. So in a nutshell, the BIOS, well, real quick, also to go along with BIOS is UEFI, UEFI, which stands for Unified. A lot of acronyms. Unified Extensible Firmware Interface. Unified Extensible Unified Extensible Firmware. Is it firmware? Yes, it's firmware. Firmware a lot of words, everybody. Many words today. So the main ones. But really, UEFI, we're not going to really get into that too much today. Mostly we're going to be getting into the CMOS, right? The complementary metal oxide semiconductor, which is this battery. Look it up. I need to look it up, actually. I'm curious. I think that's what it's referring to, this battery here, that the CMOS needs, that it uses, it lives off of. And we'll get into it. And then, so the main thing is the CMOS today, and also the BIOS. BIOS. Right, the basic input output system. Input output system. Okay, that's basic input-output system, BIOS. And then UFI. UFI is connected to the BIOS. And in newer systems, UFI is what's there in place of BIOS. And it supports faster start. Okay, so before we get into it, let's just talk about what this is basically what we're talking about today. Okay, cue the intro song. Welcome to the learning place. This is where you learn today. Okay, so CMOS and BIOS and UFI. These are the main topics today. Let's go ahead and erase this board, and we can start talking in depth about these subjects, these topics. So BIOS. So what is CMOS? What is CMOS? CMOS is troubleshoot a system. Options are different for each system, such as Lenovo computers or Compaq or Dell computers, Apple. Each system has their own CMOS. Now, what is CMOS? We'll get into it, but let's go ahead and talk about these bullet points describing the categories of what we're going to talk about for now. So troubleshoot a system. The options are different for each system. And it's the inventory list. CMOS is the inventory list. So we got CMOS. Whenever we start a computer, every day, when it starts from being turned off, so the computer starts. Here's our little laptop here, and here's all the keys. And here's our little touchpad, and so whenever we start a computer, there's something called the boot sequence. And so here the screen is black, but then when you start the computer, if you start a Dell computer, you'll see like Dell will flash on the screen here. And what's happening every time you start from scratch, a little power button here, is BIOS happens. Okay? BIOS happens. But what is BIOS? What is it? What is BIOS besides the acronym? Basic Input-Output System. BIOS is the code. BIOS is the code. So if you take this cover off of the laptop here, off of our laptop, here's the cover, and then here's just what was left that you took off, and then you see the chip, the motherboard, you've got your little CPU, you got your expansion slots, maybe you have a hard disk drive or you have an SD over here. Somewhere on this motherboard is going to be the BIOS chip. Here's a little BIOS chip. Okay. Boom, there's your BIOS chip. And on the BIOS chip is code. Code to allow all of these systems, your CPU, to check your memory, to check your expansion slots, to check your graphics processor units, your GPU, to check. So the BIOS, you turn on your computer, and then what happens right away after the computer's been asleep is the BIOS, the boot. That's an important word. That's an important boot, right? Because there's a lot of different types of boot processes. You got secure boot. You have other boots. So boot, right when you turn the computer on, BIOS boots the system and it performs a post. Okay? This last one, the T stands for test. The S stands for system. The P, performance. Let's see, what does post stand for? Performance. Hold on. Where is the acronym for post? Where is the acronym for post? Yeah, thanks. I practiced a lot. I hope you enjoyed it. Where's post? Performance system test. No, hold on. Basic input output system. BIOS. Oh my gosh. So what the post does, I'm going to find that definition later. It's in this book, this how to get the A+ certification for dummies. But what the post does is it has all these little units, the CPU and the GPU and the memory and the ports. It makes sure all the system is talking to making sure all the components are talking to each other and they're all verifying that everything is the same as it was last time, right? Because every time we turn on the computer, the system, it inventories how much data that the cache had, the memory. So the cache 1, how much memory is left. In the L1, it tells you, and it records it. How much is in the L2 cache? How much is in the RAM? Which type of RAM? What speed of RAM? How much of the RAM? And then how much of the flash drive? How much of the solid state drive? It records all of the different specifications. And it says, this is what we have. This is what we have. And so that's what it remembers. And that's all recorded in the CMOS. Okay? Which is also known as the inventory. It keeps an inventory. It's an inventory keeper. I put an inventory list here. But the BIOS, and it gets kind of confusing because these, the BIOS, hold on. What we have, the CMOS setup is stored in the BIOS component information. So the CMOS is stored in the BIOS. The CMOS is what we use. So whenever the computer boots up, and I'm still looking for the definition of post. Post is a self-diagnostic routine that the system goes through each time it boots up. Post stands for power on self-test. Okay. Power on system test? No, it was self-test, not system test. Power on self-test. Power on self. I gotta test myself. And I do that with my post. Every time I wake up, I test myself with a post. This post. I test myself. I power on and I test myself. There you go. Power on self-test. Post. That's what the BIOS does. Power on. It powers on. It wakes up. Right? We turn the computer on, and it has this boot. It boots the computer. It launches it. It launches the operating system. So we can access the GUI, the graphical user interface, which basically is what most people see in modern computers. That's what we type. We type and we see the GUI, the command prompt line. Okay, now we're getting different. So the BIOS, it boots the computer, It launches the OS, but really it performs the post, the power on self-test. Okay, with the post. Now, does that make sense? Okay, hold on. Let me read from my notes. That's a lot of words, a lot of things being said. But this is for learning, not just for entertainment. So let's see what the notes. Let's see what the notes have said, right? So BIOS, basic input-output system, is the code that's run to communicate with devices on a system. So, right, all the devices on a system communicate with the code, with the power on self-test, the BIOS. So, right, there's our motherboard here, and everything's communicating with each other. It's like, do we work? Yeah. Oh, how much? How much is stored here? How much is stored there? Does it compute with last time? Yes, no, yes. Error, or it's good, or yes, blah, blah. That's the test it performs every time it starts up. What else? Used to be, okay, so here's some information. Some history. I don't know if we need to know it, but the more you know, the more you know. So the BIOS used to be stored on a ROM chip. And ROM stands for read only memory. What does that mean? What does read only memory mean? So it means you can only read it. Not to be sarcastic, but read, and there's write. So some memory you can write on it. So you can access the memory, and here's the memory, right? That's what it looks, let's say this is what the memory looks like. And so the BIOS used to be stored on a ROM chip, ROM. So, read only memory. So basically what that is here's our example of memory. Here's our memory. And if you have read only, you got these glasses, these two eyeballs. Here's a little nose and a mouth and a face with some hair that's standing up, right? And so you got this person, they got this read, here's a ROM, it's read only. The BIOS used to be stored on the read only memory on a chip on the motherboard. So here's a person, here's the memory example, and they have the read and they're reading it. All they can do, look at their eyeballs. They're reading it. See these eyeballs? See them? The eyeballs? They're reading. Okay? That's read. That's what reading is. As opposed to nowadays. Nowadays, the BIOS is stored on an electronically erasable, programmable ROM. EEPROM. EEPROM. Electronically erasable, programmable, read-only memory. So it's still read-only, but we got this two E's and a P in front of it. So that means electronically erasable, programmable. So it can be written over, but not easily. The administrator can't just go into the system and start changing the BIOS code, changing everything. So what has to be done, because there is a process nowadays to change the BIOS or to update the BIOS or upgrade the BIOS. Throw it up. What has to be done is go to the manufacturer, go to the website, and you get some software. And on the software, you update the BIOS. There's a process for updating the BIOS software. There's at least 3 things that need to be in place in order for everything to be optimal, to be good. So first you have to make sure you have the right type. You gotta have the right type of BIOS software. You gotta have the right version. Now, each BIOS has a number or a version, and if it doesn't have the number or version, look for the year that the BIOS came out, and then go on the manufacturer's website, and then judge what version it is based off of the year, right? Kind of deduce what version you're dealing with. The third thing, whenever you're updating the BIOS, is you want to finish, right? You gotta finish what you start. If you start the update, you got to finish it. You got to, because if you don't, if you have an incomplete update, then the system will not be good. It'll be messed up. It won't work properly. What's the proper word, terminology? Dysfunctional, right? It once started, update, finish the update. Because if not, the system can become dysfunctional. So, and why would we, here's a question, why would we update or upgrade the BIOS? Why? Why update? Well, here's why. Because the BIOS, okay, let's say, here's one example. We want to install, here's our memory. Let's say we have 2 gigabytes of RAM on the system. And we say we want more RAM. We want more of that random access memory because we want our system to be faster. We want it to be faster. So if we put more RAM, let's say we want to add 2 gigabytes. So now we got 4 gigabytes of RAM. But guess what? If we did not notify, well, actually, hold on. This doesn't have to do with the BIOS. This has to do with the CMOS. All right, this is a CMOS issue, okay? Here we go. Right? Because honestly, the BIOS would be fine with this situation. I mean, because the BIOS already knows what RAM is. So it doesn't need to be told what RAM is. But the CMOS is an inventory list. So remember we talked earlier how whenever the boot starts up, the CMOS has the inventory of how much, right? How much, how fast, the different components on the computer are, how much RAM you have, what type of RAM it is, how fast is the RAM. And so whenever we start, if we add some RAM, right, we have 2 gigabytes, we add 2 more gigabytes. Whenever we start the computer over, then the CMOS is going to say, wait a minute, last time we started up, we only had 2 gigabytes. But now, we see that there's 2 more gigabytes. So there's 4 gigabytes. And so the CMOS is gonna say, wait a minute, error. It's gonna say there's an error. But really, what the CMOS is doing is noticing that there's a difference. A difference? Yes. The CMOS notices that last time we did our inventory check, there was 2 gigabytes. Right? We noticed there was 2 gigabytes last time. But this time, whenever we did our check, there's 4 gigabytes. wait a minute, what's going on? There's a difference. There's a difference. So the CMOS is notifying the user of the difference. And so it may say, do you want to save these changes? Is there really 4 gigabytes now? And we say yes. If we added it, if we did add 2 gigabytes and it's recognizing it and it says there's 4 gigabytes now, do you want to save these changes? Then we say yes. Of course. We did this. If we didn't add 2 gigabytes and the CMOS is saying, hey, error, there's a difference. There's 4 gigabytes now. And we didn't add those 2 gigabytes, then that's a different story. And that's why it's there, to report errors. So that's a whole other rabbit hole we're gonna have to jump down with our handy dandy flashlight. But as far as the BIOS and updating, so we wouldn't worry about adding RAM and it noticing that. And every time we add RAM, we don't have to update the BIOS, upgrade the BIOS, right? It used to be on that ROM chip, but now it's on that electronically erasable, programmable ROM chip, so it can be updated, right? Upgraded. The reason we would upgrade the BIOS is if we introduce something new. So let's say we want to introduce virtual. We want to start having virtual hardware on the computer. So that would use like a hypervisor, which basically we want to run a different OS on our computer, right? We got our computer, right, with our laptop and all that, and so we can actually run a different OS on what's already here. We can run more than one. We can run another computer on our laptop or our desktop. We can run an OS, it's a virtual OS, and another OS on top of the already OS that's natively here. You have 3 or more, all these different computers on one computer. But if the BIOS in some of these older systems, way older, like 10, 15, maybe 20 years, if that laptop isn't used to that kind of configuration, if it's not used to having virtualization, having different operating systems onto the laptop, then we need to update. One way is known, instead of updating the BIOS or upgrading the BIOS, is making it aware. So just make it aware. Say, hey, you go to the manufacturer's website and you get that software. Hey, you upgrade the BIOS with that software. Upgrade it. Right? After you made sure that it was the right type of BIOS software, it's the same type of the BIOS that you have. After you made sure it was the right version, the same type, the same version that you have. Right? And once you start upgrading, you finish. And so once you did all that, you upgraded it, you updated it, you made it aware, then it knows. Now it knows. Now the BIOS, on the BIOS chip, now it knows that computers can have more than one computer on one computer. Make it aware. Upgrade it. Update it. So one example of why you would update or upgrade or make aware is because of the virtualization, having many computers on one computer. Like another example would be, what was another example? Like having like a network. having a different network. What was it called? Different. Finish the updates. Built-in diagnostics, hypervisor, utilization, supervisor. All right, let's go ahead. It was an example of like something with networking, something with. We'll get back to it. We'll get back to that. Okay. So